Good morning, sir.
Good morning. Good morning. How you doing?
All right.
That's good. That's good. All right. Good morning, everyone. Hope all is well. Got a few people still trying to connect, so I'm going to give them a chance to do so. So let's give them a few seconds.
Good morning.
Good morning. Good morning. All right. All right. Looks like everybody's in that's going to be in. So good morning, everyone. Hope all is well. Hope everybody's doing all right. Hope everybody's okay. So I believe you guys have seen some of my communication. If you haven't seen all of them, I've sent like 4 emails out, and I'll show you that in a second, just to make sure we're okay with where your things will be. But my name is Mr. Tucker. I'll be your instructor for this summer. So, periodically I will be shooting you guys emails, making sure communications and lines of communications are open. If ever you are wondering if an email had been sent or haven't heard from me in a while, um, I hate it when it does that. Give me a second. Yep, there you go. All right, so if you don't feel like scrolling through your emails, you can always go to Canvas. Somebody said something in the chat. Oh, let me change my name. Okay, that's cool. Thank you. All right, so you go to Canvas and then go to your announcements. Let me get in there. And there is where I will archive all of our emails. So if I send your email out, I'm actually going to post it twice. I'll shoot it to you in an email, and I will archive your emails in your Canvas announcements. So these are the 4 emails that I've sent out. So like I said, if you wonder if I have sent out anything or haven't, you don't feel like scrolling through your emails to try to find it, you can always go to Canvas. I keep wanting to say campus announcements, but Canvas announcements, and all emails will be here. All right, any questions on that? Everybody good? Okay. Now, one of the main things I talked about is Math Lab access. So you do not have to purchase a hard copy of the book, but you do have to purchase access to my Math Lab. You should have gotten this email right here where it tells you, the website and your course ID. So let's go there. No, I don't need to do that. Here we go. So it's mymathlab.com. And you register as a student. Hit OK. Type in the course ID. So doing that, gotta put us right here. And so you see the course shell 161. If you already have an account with Pearson, you can go ahead and type it in, or you can hit create one. You do not. So once you put in your information, they'll give you 3 options. You can either either type in your access code. You may have purchased that through TCC Barnes and Noble already. One second. You may have purchased that through TCC Barnes and Noble already. If not, you can purchase access through Pearson right there, and they won't give you an access code. They will just give you access. The extra they want to give you a code. It's making things a little less difficult by just giving you access. So you pay for that. They give you access, or you can click on the 14-day free pass, which it will be a small link just like this in a sentence form down at the bottom of the screen. Where you click on that and give you 14 days full access. So if you decide to use that after the 14 days, it will lock you out. You will not lose your progress. I will still have access to your progress. It's just that you won't until you go ahead and pay for it, and then you'll be able to pick up where you left off. All right. So questions on registration? Any questions on registration? All right. So let's see. Let's get into my math lab. So when you log on, you'll have a box like this, say Math 161. Go ahead and click on that. I see a few people are already in there, so that's good. Syllabus is right here. I do need to update it, but all the same content, just need to update some dates. See how it says spring 2020. But there's your syllabus. All right, all of your homework assignments. We have test reviews in there as well that are set up as homework. So I'll talk about those in a second. Hold on 1 second. Yeah. All right, and in here, any test that we have will be under the quizzes and tests. Notice down here it says sample tests and quizzes. Do not do these unless you just want to do extra work. I can't get rid of them or remove them. So, but it says sample. So, you know, you don't do anything under that, but your tests and all of your tests will be posted up here. All right. Was that a question? Someone's on mute?
Yeah. What was the course ID?
59933.
9933.
Yep. So notice the due date says 8/8. It will not stay that. As we progress through the course, I will put the due date out there for a block of homework or that chapter's homework. So, you know, we're gonna start in 1-2, and chapter 1 goes from 1-2 to 1-7. And so when we get closer to closing out chapter 1, we'll talk about when chapter 1's assignments and stuff should be done by.
Excuse me.
Uh-huh.
Excuse me. The course ID is not working.
All right, give me we'll talk about that at the end and make sure
you have to type Tucker before it.
Oh, Tucker.
Yeah. Did you get did you see the email that I sent and all that?
No, I see it.
Oh, okay. Yeah, so make sure you stay on after we let out so I can make sure, you know, you got everything straight, got all your information and everything. But yeah, the Tucker does come before that. I thought you were just asking about the number. All right. So right now the due date says 8/8, which is our last day to submit any assignments. But that's not going to stay that way. It's just a date just out there right now. As we progress throughout the course, I will change that date, and I will give you a heads up, couple weeks heads up as to when that date or what that due date will be for chapter 1's work. Same thing we'll do for chapter 2 and so on. So there'll be one solid date for chapter 1, one solid date for chapter 2, solid date for chapter 3, and so on. So that's how we'll do that. Any questions on that due date?
So I got a question.
Mhm.
Is there any way we could check our like overall grade or like status of where we are in the class?
Yeah, once you submit an assignment, you immediately get a score. So you'll have your grades. Like, so there's nothing for me to send to you. Once you submit your grades, or once you submit an assignment, you will get a grade. And so you will immediately know where you are. Same thing with the test. Once you submit, hit submit on your test, it will tell you what your grade will be.
Okay.
And then from there, if you want to email me and say, okay, you know, just to be sure, then we can do that. But I wouldn't be able to see anything until you actually hit submit.
All right. So I got another question. The username to get in your Pearson and your password. What is the username and the password?
You know what, man? I'm gonna fight you, man. We're gonna fight on the first day. We gonna let me say after class, and we'll knock this out, man. I want to make sure you're straight,
Right.
because like, you know, they don't want to hear none of that. they want to do this general course stuff and get out the way, and then as soon as I get them out of the way, then I'm gonna get you and make sure you're straight. Because I don't want to just the reason why I'm saying that, because I don't want to just gloss over it, and then you have to come back for another question. You know what I mean? So I want to give you my full attention, but I got these other students that's like, they ain't got nothing to do with me. You know what I'm saying? So let's just pause on that. Let me go ahead and get through this general stuff, and I can send them out the way, and then I can make sure that you're straight, because it might be something else that I have to answer too. So that's why I'm saying, let me make sure, you know what I'm saying? I want to be able to give you my full attention when it comes to that. So yeah, just hold off on that, because I'll make sure you're straight before we leave.
All right.
And so some reason won't let me change my name. But yeah, okay, that was somebody else. Yeah. And of course, I was joking about fighting you. I can't virtually hit you. Man. I was just joking, just throwing it out there. The next thing I know, I'll be getting getting emails about he was fighting a student, trying to fight a student. But just joking. So yeah, so just want to make sure we're clear on this due date thing. It's not going to stay 8/8. So I want to make sure that we see that. It's just out there right now. That's the last day of submission for anything, right? And then, but as we progress through the course, chapter 1 will be due at a certain date. I won't know that until, because I try to leave it up in the air because, you know, depending on how fast we move, how slow we move, you know what I'm saying? I don't want to put a date and then have to change it anyway. So this way it gives us flexibility to be able to set those due dates. Now, when it comes to your test, every test is not going to just be, you just do it whenever you want to do it. Because I do have to see you at some point sitting in front of a computer doing something. Outside of that, you could just be getting little Johnny from down the street to do all of your work. You know what I mean? So there will be proctored tests. I'm not going to make the first test proctored. So you will be able to do that on your own. Any test that I, shoot in my math lab that you can do on your own will not be timed. You will get 2 attempts to get the best grade possible on it. Any test that will be proctored will have a password on it. You won't have access to it until the day of. So we'll talk more about that as we get closer to it. But that first test that's up there, you are able to do it on your own at your leisure. And like I said, we'll put a due date on that, when we get closer to closing out chapter 1's content. Let's see. I think that's it for that. Okay, attendance. Let me say this. As far as lectures go, I will be recording all of the lectures. You are expected to come to class. If by some chance you can't make it, I'm recording the lectures. I will shoot you guys the link, probably on a Friday, after we've recorded both sessions for the week. Send those to you, and then you have access to them to review, whether you sat in class or not. So just shooting that out there. Classes will be recorded, but the way you solidify your attendance will be through my math lab. I sent that to you in my math lab specifics. We'll talk more about that. I'm gonna pull that up and make sure you guys are okay with the details on it. But you do want to be active in my math lab. Don't forget you cannot pass without being active in my math lab because you have to submit your assignments. So just throwing that out there. Also, you do not, just throwing this out there again, you do not have to purchase the hard copy of the book because you have your e-text right here with all of the chapters. And there is, the book is embedded in the My Math Lab Access. All right, so let's go to what an assignment looks like. Let's see what we're looking at. Okay. Sorry about that. All right, here we go. So whenever you're doing your assignments, you will have to help me solve this. Not help me solve this. You have this help box, toolbox. In there, you have help me solve this. Most of the time, you don't click on that unless you're just done with the problem. You're frustrated. You don't want anything to do with it, but you want to see how it was done. You click on that. It'll walk you step by step through the problem that you're looking at. And then from there, it will reset the problem in order for you to try another problem that's similar to it. So most people don't click on that. Most people click on view an example. Click on view an example, it opens up an extra box or outside box wherein it'll walk you step by step through the problem that's very similar to the one that you just finished looking at. And then you can close it out and then go back to the problem you want to work on. Some videos, or not some videos, some problems will have videos that will help you to, give you another lecture on it, on that type of problem specifically. Animation is very similar to it as well, similar to the same concept. Click on textbook, it will send you to the place in the textbook where they talk about this type of problem. Ask my instructor will shoot me an email. Sometimes that works, sometimes it don't. So don't forget to, if you don't hear anything from me, to go ahead and email me yourself. And then you can print this out if you want to. Skill Builder will create problems for you to help solidify your ability to be able to do this type of problem. So not too many people click on that, but that's how you get extra help. or extra problems for help. All right, so the way this works, I'm just gonna click on this one. Here, check your answer. Try to give you a little bit of a hint. Try to give you a hint, and then notice to give you 3 shots to get the answer correct. Now there are certain ones that, maybe definitions or something like that, concept check, where they may not give you 3 chances. It may give you 1 or 2 chances, but that's because they're not calculation based. But normally calculation problems, they give you 3 shots to get the great answer correct. If you get it incorrect, they'll give you opportunity to do a skill builder, or you can just close it out. So notice here you have a red X. If you go back and do it correct, you will get a green check that will give you full credit, let you know that you got it right, and it'd be like you never got it incorrect. If it's a problem that has multiple answers, you can get one right and maybe get other ones wrong. Then if you do that, you get a green check / red X, like you got partially correct. Then if you were to go to the problems, you'll see which ones you got wrong, and you can just go to that problem versus scrolling through. Also, if you want to reset the problem, you hit similar question, and there it goes right there, and that's when you can do it again and get the answer correct. You get unlimited amount of tries to get the best grade possible in your homework, and I will talk about in a second how we do the scoring on that, but unlimited amount of tries to get the best grade possible in your homework. So before we go any further, questions on that? Everybody good? Everybody straight?
I actually had one quick question, sir.
Yeah, no problem.
In theory, is it possible to get the 14-day trial, knock out all the work we need, and be good for the semester?
It is possible, but the only way you would do that, because all of your tests aren't posted, and so you would have to get with me on the test that I am going to proctor, and your final exam has to be proctored as well. So the only ones I know for a fact, as far as how I'm doing it, as far as your tests are concerned, because that would be the only hiccup in that. Like if you just had access to all of your assignments, yes, you could do it that way. But I do have to, like I said, at some point see you, for the sake of, the integrity of the course, see you sitting in front of a cute computer during the designated time. So we would have to work out, okay, when are you going to get, like your final exam has to be proctored. And then whatever other tests I decide to do, proctored. But yeah, in theory, you could do it, but those proctoring moments would be something we would have to work out.
Gotcha. Thank you.
Yep, not a problem.
I got a quick question too.
Yep.
So for the tests that are going to be proctored, are they going to be through MyMathLab or another format?
Yes, they'll be through MyMathLab. And I'll give you guys details on it when we get closer to it, or we decide, okay, test 3 will be proctored or whatever. And we'll talk about it multiple times to make sure everybody's clear on what we're going to do and how we're going to do it. So it still be through MyMathLab. You will see the test you will see the option of the test prior to that day. But if you click on it, it will ask you for a password. And of course, that means you can't get a password unless I give it to you. So I wouldn't give it to you until test day, that do a block of time that we're going to take the test, the class time, that we'll take the test. So what would happen is every camera, you would enable your cameras, during lecture time, you can be, your camera can be blacked out. It doesn't matter. But on that day, your cameras will be enabled. Of course, we'll be recording the session. You show, picture ID. And then you would just take the test. I'll give you the password, then you would take the test with your camera still enabled. And that's how you do it, for the time. Well, we meet from 11 to 1. So from 11 to 1, you have that block of time to take your test. I also offer makeups, and we'll talk about all of that. But I also offer makeups for those, during the proctor time, you took the proctor test, didn't score what you would like. Then I'll give you a makeup opportunity, and we'll talk about the details of that as well. So there will be opportunity to get the grade that you want, so yeah, most definitely.
All right, sounds good. Thank you.
All right, no problem. Okay, not a problem, not a problem. All right, any other questions on anything up to this point?
I did have a question about the show me the, I forgot what the under question help, it says show me the, help me solve this. Does that affect the score in any way?
No, what it will do is it'll go through the problem step by step, and then it will reset the problem so you can try it on your own.
Oh, okay, cool. Thank you.
Yep, not a problem. So all it is really just like going through the problem, then hitting similar exercise to try it again. So now it will not give you credit for it because it walked you through it, itself, but it will give you the opportunity to get the credit on your own. All right, anything else? Anybody else? Make sure we're good up to this point. All right. So let's look at, since we're here, where is it? Where's my part? All right, so I sent this to you. It's called My Math Lab or Math Lab Specifics, just telling you how we'll be using Math Lab, writing it out, even though I've said a lot of this stuff, but just putting it on paper just in case you want to reference it. Once again, I shot it to you in email, but if not, I showed it to you in your Canvas and Canvas announcements as well. It's entitled Math Lab Specifics. So once again, you cannot pass the class without access to My Math Lab. All the assignments and tests, whatever we do, will be generated through MathLab. Like we mentioned when your classmate brought up, even your proctor test will be generated through MathLab. So I'm not going to bring anything new to the table. No other, websites or anything like that. We're going to do everything through MathLab. Try to make it as easy as possible. Your attendance, like I said, you are expected to come to class. I'm expected to come to class. I didn't even know that it was possible to just shoot you guys video and then go on about my day and still get paid. I just found out that from another class. They were saying that most of the teachers just shooting them videos. But we'll talk about how we will be doing lectures. But I'm teaching real time. Yeah. So you are expected to come to class. I'm expected to be here at the appointed time. If by some chance you can't make it, no harm, no foul. I will be recording all lectures, and then I'll make a YouTube video, shoot you the link before the week is out. Oh, okay. Shoot you a week before the link is out. And so you'll still be able to go to it. So if I don't catch you through Zoom, then the way you solidify your attendance is through My Math Lab, participation and activity. If you're not, well, I won't say if you're not. The way I most definitely know that you are active is through My Math Lab. That puts a date stamp and a time stamp on it. Also, let's say you haven't went to class. If you at least get into Math Lab and nothing more than save, a homework assignment, go in and submit, because you can go in and out of your homework. So at some point you can go in your homework, submit, maybe you have 40%, but then you can go back in there, do some more problems, raise it to a 90%. You know what I'm saying? You can go in and out of your homework at all times. Now your tests don't work that way. I'm just talking about your homework. Now your test, once you hit submit, that is it, because you're supposed to sit in your test and knock it out. But your homework, you can go in and out, at your leisure. So if nothing more than just going in your homework and hitting save, that's a time and date stamp that I can reference to, whenever they ask me about attendance in the course. Once again, you have unlimited amount of tries to get the best grade possible on your homework. So with unlimited amount of tries, does not come unlimited amount of problems. So I know at some point, if you keep clicking on it, you'll get the same problem that you got, a couple clicks ago. So that's why I hear the lowest score that we're looking at is 75. So between 75 to 84.9, that will be a 90% in my grade book. Then 85 to 100 will be considered 100%. So if you want credit for your homework, you want to at least get a 75. And then to get full 100%, get 85. All right. Any questions on that?
I have a quick question.
Yep.
Are tests going to be treated like homework, as in we have to do it on our own time after class, or are we going to have a class period to do our tests, like the ones that aren't proctored by you?
Okay, so the ones that are not proctored, you do them on your own. The ones
Okay.
that are proctored, yes, there will be a class time set up for that.
Okay, thank you.
Yep, not a problem. All right. So then here, test reviews. Test reviews are not mandatory. Those are set up like homeworks as well. You can do them unlimited amount of tries.
Wait, I got a question.
Uh-huh.
So, like the tests that are not proctored, do we need like a webcam? So like you make sure like we're not cheating or anything like that?
No, you just do them on your own. You basically on the honor system, and you need to send me your scratch work.
Mhm.
Yep, basically on your on the honor system. So that's why at some point we do have to have a proctor one because, like I said, anybody could be doing your work if we never do a proctor test. You know what I mean? So that's why at some point at least I have documentation that at some point you did sit down and take a test. You know what I mean? So now there are instructors that are doing it that way and they're real strict with it. You have to have multiple devices. You have to have the lockdown browser. You have to have your Zoom camera on, and then you have to have your phone or some other device that's looking at your hands. Like it's getting real for some people. But I'm just like, man, if you're going through all that to cheat, then you got me. Like, you know what I mean? I'm not gonna. I'm not. It's not that stressful for me. I mean, as long as I got a couple times in there, a couple moments in there when you re-record it, and it shows, and I can actually, hey, this person was here, and then I'm good to go with that.
For like the proctor test, could we just like look at like our old works? Would that be considered cheating?
No, you can use notes. I wouldn't do that. It's fine to use notes.
So are we also allowed to use like online outside sources as well for like our proctor tests?
Yeah, just remember that it is time. So whatever you guys use, just make sure you are efficient with what you're using. And also, like I said, don't forget I am looking for scratch work. So if you're doing something like Mathway, wherein it just gives you an answer, don't forget I'm looking for scratch work.
Right. How would we like submit our scratch work? Do we just like send that through email?
You could, you shoot to me through email. You can either take a picture of it with your phone, shoot to me through email, scan it, whatever way.
Okay.
It's not that bad. Not that big a deal how you send it to me as long as you get it to me.
Right. All right. Thank you.
Yep, not a problem. I think I heard somebody else. Was there anybody else that had a question?
Yeah, I was just going to ask the same question about the scratch work, though.
Okay. Yep. Whichever way. Most time, I know some people have sent it to me through Canvas. I think there's a way to send it to me through Canvas, but the easiest way for me, I think with Canvas, sometimes it don't always pop up. Like it does some conversion thing. I don't know. But I know if you just shoot it to me through email, just straight to my email, btucker@tcc.edu. That's
Now,
the easiest way.
And then does it have to be like detailed scratch work, or like because a lot of the time I wind up doing the problems in my head and working it out in my head. So do I have to have like at least one problem? Is there like a guideline on the scratch work, or is it just like whatever you do, send it?
Well, whatever you do for the most part, because at some point there's going to come a point in time, you might be genius like that, but at some point it'll come a point in time where you will have to write down something because of the problems that we're doing and the processes. But just write down as much as that it normally takes. I'm not going to be that strict on that.
Okay.
Yeah. All right. Anything else? Anybody else? All right. I think that's good. Okay. I think I mentioned this already. You get 2 attempts, and you'll see that in my math lab, your attempts on your tests. So that test 1 that's not being proctored, you get 2 attempts on that. So whenever there's a test that's just thrown in there, you will get 2 attempts to get the best grade possible. All right. I think that's it for that. Let's see. Anything else? I'm good. Oh, just a heads up. For those of you who have to take 162, we use the same book for 162. So your math lab, this Pearson code, should be able to, it's supposed to be able to be used twice as long as you're using the same book. So you should be able to use this same code for, well, not same code, the same, access code, same access code for 162. It's supposed to be anyway.
162 is calculus, or what's 162?
That's pre-calculus 2. Yeah, so this pre-calc 1, and that's pre-calc 2. So that gets into trig. Yeah. All right. As a matter of fact, we stop at chapter 4, and we do a few sections outside of that, but main chapters, we stop at chapter 4. Pre-calc 2 starts in chapter 5. All right. Any other questions before we go anywhere else? Okay, cool. So now this is normally a 16-week course. We have 10 weeks to get it in. We got a 2-hour session. So I don't plan on talking for 2 hours straight every single time. Well, I don't ever plan on talking for 2 hours straight. It's just not my flow. So every day will be an opportunity for questions. Also, if you have or you desire to meet with me outside of class time, I found that in this season it's easier to just talk about when we both can meet versus me setting up office hours that you probably won't be able to meet, and then we have to talk about it anyway. So, you know, if you want to set up a meeting outside of these classroom hours, feel free to shoot me an email, and then we can match our schedules up and see what fits both of us, and then we'll go from there. So if you ever need extra help or outside help, you know, it's always there. It's always opportunity for that. But once again, every class period is opportunity for questions as well. Also, because we only have 10 weeks, we do have to get started with a little bit of lecture today. So before we do that, is everybody good at where the class is going and how we're flowing?
Calculators are allowed, right?
Yes. Yep. Calculator is not a problem. So I think we're good to go. So let's talk about a little bit of solving equations. Then I'll let you guys go for today. And so the way we will be lecturing, or the way we will have our classes, is that, go right here. So we will be, well, I'll be writing on this whiteboard. You see, I got all my stuff. I'll be erasing this stuff as we go through it. And then as we, you know, as I write, you know, I'll be talking the same. So learning virtually and learning online are two different things. You know, you're not learning online. You're not learning by yourself. In other words, I'm not just shooting you a video and you'll never see me. Every day, you know, I'll be talking to you just like we would be in a face-to-face class. So just like we would be in a face-to-face class. So it wouldn't be any real different experience other than the fact that you're in your room and I'm in my room. But, you know, you can ask questions, you know, you can say, hey, if I scroll down too fast, can you scroll back up? I was still trying to copy the last little bit. Ask me to repeat that. All of those opportunities that you would have if we were in face-to-face setting is the same, or will be the same opportunity that you have, you know, doing these class periods, these Zoom sessions. All right. So let me see. We got 1, 2, what's 1, 3. All right. So we'll just do 1, 2 today, and then you know, pick up where we leave off on next class. All right. So 1.2, linear equations and rational equations. So we're looking at solving equations. An equation is just a statement that two algebraic expressions are equal. I think I want to make that blue. All right. So an example of that is x plus 5 equal to 7. Just a simple equation. X plus 5 is equal to 7. All right. So a solution would be a value or values that will make an equation true. So in this case, x equal to 2 would be our solution. You know, you ask yourself whenever you're looking at an equation, when is this equation true? Or in this case specifically, when is x plus 5 equal to 7? And your answer is when x is equal to 2. You can always check your equation by plugging it into your original, plugging the solution. You can always check your solution, excuse me, by plugging it into your original equation. And so, you know, plug it in for x, 2 plus 5 is equal to 7. So we will be solving by what I call opposite operations. Addition and subtraction are opposite operations. They undo what the other one does. Multiplication and division, same thing. They undo what the other one does. And so this section really doesn't go through the basics. I'm just going back there just to make sure we're all in the same spot, same place. You know, it'll pick up in a second. But just want to make sure we're all in the same spot. So when it comes to your equation, let's go back to x plus 5 equals 7. We want to undo what's being done to the x. We have our x, and we want to get x by itself. So if we have x plus 5, I need to undo the addition of 5 by subtracting 5. Also, our equation is split into two parts. We have a left side of our equal sign, right side of our equal sign. So whatever's being done to the left side of your equal sign, you have to do to the right side in order to keep your equivalency. So if I minus 5 from the left side of my equal sign, I need to minus 5 from the right side as well. 5 and negative 5 will cancel, leaving with just x on the left. 7 minus 5 is 2, and on the right, and that will be my solution. Once I have my variable solved for and singled out by itself, then I have my solution on the other side. And so that is the foundation of solving equations. Your goal is to get your variable by itself on one side of the equation, and the way you will do that is by performing the opposite operations to do so. All right. So just simple one calculation problems, equations. If I have y minus 10 equal to 15 and I want to solve for y, I'm going to add 10 to both sides. The 10 cancels on the left, leaving me with just y. And then on the right, 15 plus 10 will give me 25. So y is equal to 25. All right. Over here, 5a equal to 13. If I wanted to solve for a, I would divide both sides by 5, because that's 5a is 5 times 5. So I'm going to divide by 5 to undo the multiplication of 5. 5's cancel, and that leaves me with 13 over 5 as our answer. All right. So now notice I left my answer as 13 over 5. That's because it cannot be reduced. You do not have to convert that to a decimal or write it as a mixed number. 13 over 5 is good enough. Now, if you can reduce it, you are expected to do that. So what I mean by that is right here at 4 over 6. This is reducing your fraction. In other words, if I have 4 over 6, 4 is 2 times 2, 6 is 2 times 3. I can cancel out the 2, and that leaves me with 2 over 3. So that's reducing a fraction. But you still can leave it as 2 over 3. You don't have to convert it to a decimal. So just throwing it out there. Because remember, whenever we're doing math, and don't forget we're human, the more steps you give yourself, the more chance you give yourself at an error. You know, if you were to convert this to a decimal and you write down the wrong decimal number, then it's now wrong, right? But 13 over 5 is good enough. All right, and looking at this last one-step equation before we add more to it, we have x over 9 equal to 11. So that's x divided by 9. So in order to solve for x, I will multiply both sides by 9. 9's cancel, and x is equal to 99 as our answer, our solution. So questions on any of those one-step problems before we add more to it?
Could you scroll up a little bit? I missed some part of the notes.
I don't know how far you need. How far are we going?
Oh, just right there, the opposite operations.
Yeah.
Thank you.
Mm-hmm. Let me know when you finish.
Is this gonna be on like Canvas or anything, or is it just like for you?
What you mean?
Like the whole notes thing, like.
Well, I'm going to post the lecture the actual video, where you can go back and review it and pause it, and write whatever you like to write and go back, like that. But the actual notes, I don't really have a way of putting that in Canvas.
I got you. Sorry, thanks.
Mm-hmm. All right, so somebody's speaking of notes, will we have access to them on Canvas or through Zoom only? So I think that's what he was just asking about. So the notes themselves, I don't have a way to post them. I thought he was cussing. I read that all types wrong. So
Oh, you were cussing at me too. I got concerned.
you saw that, right? But it's all good. It's all good. So I thought that he messed me up with that. I don't have a way of posting or transferring these notes, and maybe I do. I just don't know how to do it. I'll say it like that. Of transferring these notes to Canvas or to to a way like that. But I will post the actual lecture. So when you go to review the video, what you can do is pause it whenever you feel like and rewind it and stuff like that. So yeah.
Perfect. Thanks, Professor.
Yeah, not a problem.
Okay, I'm good.
All right, cool.
Thank you.
Not a problem. All right, so let me erase some of this stuff, y'all. Yeah, I can leave that like that. Okay, so the original problem, 2x plus 1 equal to 17. So now your goal, once again, is to get x by itself. We have two things being done to x this time. We have it being multiplied by 2, and we're adding 1 to it. So we could move the 2 first, or we can move the 1 first. Now, the most efficient way to deal with this problem is to move the 1. Now, if you decide to divide by 2, don't forget you have to divide everything by 2, but now you're creating fractions for yourself, and most people don't want to deal with fractions. So let's go ahead and subtract 1 first. Subtract 1 from both sides. 1's cancel. That leaves us with 2x equal to 16. And then divide both sides by 2. 2's cancel on the left, leaving us with just x. 16 divided by 2 is 8. And that's our solution. All right. Problems, any problems? All right, can we scroll up? Good. All right, the next one, we have 2 times the quantity of x minus 3 minus 17 equal to 13 minus 3 times the quantity of x plus 2. So notice we have these parentheses that have x involved, but we don't have access to the x until we remove the parentheses. So the first thing we want to do is distribute. So we'll take the 2, distribute into the parentheses, and then here, be careful, make sure you distribute the whole -3, not just 3. So you distribute -3 into the parentheses. And that'll leave us with this expression right here, or this equation. That'll be 2x minus 6 minus 17 equal to 13 minus 3x minus 6. All right. So now before we move, and this is what I always suggest, before you move anything across the equal sign, before you start doing opposite signs, it's better to go ahead and simplify as much as you can on the left side, simplify as much as you can on the right side. Like I said, before you move anything across your equal sign. So on this left side, we have -6 and -17, which will give us -23. And we erase this. And then on the right side, we have 13 and -6, which will give you, I said 13, yeah, 13 and -6, which will give you a +7. Oh, okay. All right. Any problems with that before we go to the next step? And whoa, drop my pen. So here I was just emphasizing that you could have written that as -3 plus 7. Those are the same expressions. As long as the 3x is negative and the 7 is positive, it's still the same expression. So don't forget your goal is to solve for x, get x by itself. Notice that we have x in 2 different places. So you need to get all of your terms with x to one side of your equation, all of your terms without x to the other side of your equation. And it doesn't matter which one you move. You got 4 different terms. Doesn't matter which one you move first. Just know that ultimately, if you do everything correctly, you'll still get the same answer. All right, hold on 1 second. Sorry about that. All right, so I'm going to add 3x to both sides. Like I said, you could have moved the 2x to the other side by subtracting 2x. It doesn't matter, you'll still get the same result at the end. But adding 3x will cancel out 3x on the right. Erase this. And so that'll give me 3x plus 2x, which is 5x minus 23 equal to 7. Now I'm going to add 23 to both sides.
Damn. Damn.
Oh, sorry.
Was that a bam because you're excited because you got the answer, or?
Oh no, I got the answer from Professor Tucker.
Nice to see you again.
You too.
Oh, y'all, let me say that. Not again because she failed the class last time. I had her in another class and she's in this class. So that's right. So I want to make y'all think that she failed. She good. She good. She good. All right. So now we finish it off by dividing both sides by 5. And answer is x equal to 6. All right, questions? Any questions? All right, can I scroll up or somebody still copying? All right, so our next problem, 5x minus the quantity of 2x minus 10 equal to 35. So just like before, whenever we have parentheses, if there's anything sitting in front of the parentheses, we do have to distribute it so we can get rid of the parentheses. Now, if it was just a plus sign, there's nothing to do there. You can go ahead and drop the parentheses, but we do have a minus sign there. So that minus sign does affect each term that's in the parentheses. So distribute the minus sign, and that'll give us 5x minus 2x plus 10 equal to 35. Once again, we have terms on the same side of the equation that are common, so we go or like, so we go ahead and combine our like terms. And that'll be 3x plus 10 equal to 35. Now we can subtract 10 from both sides. That'll be 3x equal to 25. Divide by 3, and our answer is 2503. Oh, okay. All right. Just making sure. Look at something real quick. So any questions before we go to the next one? Real quick, Philip's iPhone. Is that Philip Bailey? Because I just saw your email saying you couldn't get in. So I need to know if I need to go.
Yeah.
Okay. I just saw the email and sorry about that. All right, cool. All right, so let's look at the next one. So here we have x plus 2 over 4 minus x minus 1 over 3 equal to 2. So the best practice here is to clear out our fractions. You do have the option of sticking with them and trying to work it out, but most people would like to get rid of fractions if they can. So we're going to clear out our fractions. First thing we want to do is find the LCD, and that green circle right there is just a note as to, a reminder as to what your LCD is. It's the smallest number that each denominator can divide into evenly. So not what can divide into them, but what those two numbers can divide into evenly. So in this case, that will be 12. We have 4 and 3 as our denominators. Our LCD will be 12. All right. Then you're going to take that 12 and multiply each numerator, whether it has a fraction involved or not, whether it has a denominator involved or not. You're going to multiply each numerator by the LCD. All right, so let me erase some of this stuff. I didn't want that in there. All right, so that's what we did here. Multiply each numerator by the LCD. Any questions? Hold on one second. Let me look at something. I'll put these. Let me do this like this. I probably should have left that one. I like that better. Okay, so the next step is to simplify. So in other words, I'm going to take this 4, divide it into the 12, leaves you with 3. This 3 divides into 12 and leaves you with 4. All right. So once you do that, this is what you'll be left with.
No, I'm using it.
Say it again.
Oh, my bad.
Oh, okay. All right. Not a problem. Questions on the simplification before we look to solve? All right. So once you've gotten rid of your denominators, now you have a regular equation, and you can go ahead and distribute and go about solving, which is your fourth step. We're going to distribute 3, distribute -4 here. So that'll be 3x plus 6. Oh, let me do that. Yeah, so 3x plus 6 minus 4x plus 4. So don't forget, like I said, to shoot that -4 into that other parentheses. Then we will combine our like terms. Oh, somebody's saying something. All right, on which part, Miss Allen?
Personally, I was wondering why we don't distribute the 12. I haven't done math since high school.
I guess.
Well, let me get one question at a time real quick. So if you distribute the 12, you could, but you still got to go through the process of dividing the 4 into each one of those terms. So this eliminates you doing that more than one time. So if you distribute the 12, then you're gonna have to divide the 4 into this and to this. Then if you distribute 12 here, you divide the 3 into this and to this. But if you just do it one time, the division part is over. Now you're just distributing. So Ms. York, did that help?
Yes, I just didn't know that was I haven't done math in like 6 years, so I didn't know it was a possibility.
Yeah, not a problem. Now, like I said, you can distribute. You're still going to get the same result. It's just that so basically I divided and then distributed. You would distribute it and then divide it. So you would still get the same result. It's just that don't forget that this four has to go into each term, not just one. And then you'll be fine.
All right, cool. Thank you.
Not a problem. Miss Allen?
I just didn't. We were supposed to multiply the numerator by 12, right? Because 12 was the LCD. But where is the answer for that? Where are your answers for
now
the numerator divide times 12?
Well, this is that process right there. You multiply everything by 12.
Yeah, but I guess I just don't see where you multiplied everything by 12. Is 12 your final answer? 12 with the
no.
Where's your final answer?
Well, we haven't gotten to the final answer yet.
I mean, not for the problem, but for the answer for 12 times the numerator.
Right. Well, see, this right here is 12 times 2. Right. So now we are multiplying each thing by 12, not to do the multiplication for the sake of multiplication, but so that we can clear out our fractions. So we're just using the process to get to the clearing out our fractions part. So we're not necessarily sitting back looking for the result of multiplying it by 12, but the result that we're trying to get to is right here, no more fractions. You see what I mean? I think you're looking for a step, a part in the process that we're not really focusing on because we're just using it to get to somewhere else.
Yeah, but you know I'm an overthinker.
Yeah, I do. I do. Y'all, I had her in another class too. We done been through this and done this. But it's all good. So yeah. So I understand what you're saying. Yeah. So like right here, 12 times 2 is 24. But the only reason we see that result is because there was no denominator to mess with the 12. So now in these other two, we have this 12 that's being multiplied to the numerator, but this 4 is going to divide into that 12 before we do the multiplication and leave us with just 3. And that's how our denominators, that's how we remove the fact that we have fractions. Right? Does that help? You see what we did?
Yes, thank you very much.
Okay, cool. So I'll make sure we're good before we keep going. So, let me go here. Yeah. So now we're at this point where we have no more denominators because we divided the 4, divided the 3 into that LCD at 12. We could go ahead and distribute, and that leaves us with 3x plus 6 minus 4x plus 4 equal to 24. Now we can combine the like terms. Remember, we have like terms that are on the same side, so we're not using opposite signs. We just combining the like terms. So 3x and negative 4x is negative 1x. And then 6 plus 4 is 10. So that's what we have right here. Negative x plus 10 equal to 24. To finish, well, we're still looking to get x by itself, so I won't say to finish it because we have one more step. But we'll subtract 10 from both sides to be the next step. And that'll leave us with negative x equal to 14. So don't forget your goal is to solve for x, not negative x. So we need to get rid of the negative, and we can just take that negative, shoot it to the other side. And the result is x equal to negative 14.
I have a quick question. How did you get negative x?
Because we had a positive 3x minus 4x. And that'll give me a negative 1x.
Okay, thank you.
Yep, not a problem. And just to reemphasize that whenever you guys see x, that's the same thing as 1x. So they do assume, and I ain't saying that this is what she was asking, I'm just throwing it out there for anybody who may have been wondering why I was saying negative 1x. So whenever you see an x, they assume you know that there's a 1 in front. Same thing with a. Any variable, they assume you know that there's a 1 in front of that, but they're never going to write 1. So just making sure we're clear on that. They're never going to write 1, but they assume you know there is a 1 there. All right, questions before we go to the next one? All right, so the next thing, intersection of rational equations, very similar to what we just did with clearing out our fractions, what your variable may be in your denominator. So here we have 1 over x equal 1 over 5 plus 3 over 2x. So once again, you're looking for your LCD. Notice we have x, 5, and 2x. So we're talking about the smallest combination of these expressions that each one of them can divide into evenly. So you see that the most we have is 1x, so all we need is 1x. And then 5 times 2 would be 10. So this 10x gives room for 5 to divide into it. Or if I divide it by 2x, that can divide into it as well. So that's a combination of all three of those denominators, that 10x. We have 5, 2, and x. So you don't write anything repeated. So in other words, I wouldn't just multiply them together and do 5 times 2, which is 10, x times x, which is x squared. So that is a denominator that you can use, but you don't want to use. That's not considered your least common denominator. So you just would take each one that's not repeated. So we have x, 5, and 2. And like I said, this is repeated because we have x here, so we wouldn't use it. And that's how you get your 10x. So before we go any further, everybody okay with how we got 10x? We use the x, the 5, and the 2. All right, so that's the first step. You find your LCD. Second step, let me erase this stuff so we can see it. Second step is to multiply each numerator by the LCD. So we took that 10x and multiply each numerator by the LCD. So like I said, we're just following the same steps, that we did in the previous problem. Found the LCD, then we multiply each numerator by the LCD. Next step is to simplify. So now I have x. Don't want to go red, let's go green. X that can cancel with this x, and that leaves me with 10 times 1. This 5 cancels with this 10, cancels into the 10, and leaves you with 2. 2 cancels into 10, leaves you with 5, and then also this x cancels out. So when we look at our result, this is what we're left with. 10 times 1, which is 10. 2 times x times 1, which is 2x, and then 5 times 3 is 15.
So I got a quick question.
Yep.
Can you eliminate the denominator without simplifying the top part?
What you mean by that? Let me make sure I understand what you're saying.
So like how you put, for the second number, how you put 2 to simplify, basically how you simplified everything on the top. Can you just can you just get rid of the bottom numbers without simplifying the top?
So now I just want to make sure we say without simplifying the top. So now are you saying without? So when you say without simplifying the top, what do you mean?
Without simplifying the numerators, I think.
Okay. So now what I did, right, let's say right here, I have this 10x times 1. Now, so are you saying doing it without multiplying it?
I think so. Like how you how you cross that out and you put, so like for the third number, I'm looking at the third number right now, how you crossed out the 10 and put a 5.
Right, over here.
So instead of doing that, can you just put like 10x equals 10x plus 10, sorry, is it 10, 30x?
So you're saying, can you multiply it and then reduce it?
Yeah, that's one.
Yeah, yeah, most definitely. Yeah, that was that's what I was mentioning to one of your classmates before. She was asking about distributing 12. So actually multiplying those numbers out. Yeah. So what you can do, like you said, if you were to multiply this out, that will give you 30x over 2x, and that still reduces down to 15.
Okay, so basically you're just doing that later on. If that was
Yes. So when it comes to this process, you can either uh, multiply first and then divide or reduce, whichever way you want to call it, or you can reduce first and then multiply. So what I've been doing is reducing first and then multiplying. But if you want to go the other way, that's fine. I'm just doing it this way. A lot of times, I just got a habit of doing it this way because I've dealt with large numbers in the past. So if you do it this way, I'm dealing with the numbers in their smallest form, and they're easier to reduce here before you get to a larger number, which may be more unfamiliar. You know what I mean? So, but either way is fine. You'll still get the same answer if you do it correctly.
I usually do it the other way, so I just got a little confused there for a second.
Yeah. So yeah, you can do it the other way. As long as you get here, 10 equal to 2x plus 15, you're still in a good place.
All right, thank you.
Yep, not a problem. All right, so next move is to subtract 15 from both sides. That'll leave us with -5 equal to 2x. Then finish it off by dividing both sides by 2. And that'll be -5 over 2 as our solution. If we talk about our steps, this should have been step 4 when we actually go to solve. All right. Questions before we look at another one? All right. Next one. X over x minus 3 equal to 3 over x minus 3 plus 9. So when you look at a problem like this, this is a whole denominator. So it's not like it's 3x. 3x, would be your whole denominator, but I don't want us to see a 3 minus, x minus 3 and consider x as a part of a denominator. 3 is another, that x minus 3 is your whole denominator. So notice that we have the same denominator in each case, so that will be your LCD. All right. And so you multiply, let me erase, multiply each numerator by the LCD. Because remember, your goal is to get rid of the fractions that we have. All right. Now that whole quantity of x minus 3 cancels in the first one. The whole quantity of x minus 3 cancels in the second one. And then this 9 would be distributed to each term in that third quantity. That leaves us with x equal to 3 plus 9x minus 24.
Does it matter where you put the 9x and the 27?
No, as long as the 27 is negative and the 9x is still positive, you're all right.
Okay.
All right. So we have like terms, 3 and the negative 27. That will give us negative 24. So now we have x terms on two different places or two different sides of our equation. So we want to get our x terms all on one side. And so I will subtract 9x from both sides. That will give me negative 8x equal to negative 24. So don't forget there's a 1 in front of this x, positive 1. Then over here, divide both sides by negative 8, and our result would be x equal to 3. All right. Questions on that before we look at one more thing about this solution?
How did you get the 8?
Right here, when I subtracted 9x from both sides, because I needed to get all of my x terms to one side of my equation. So I subtracted 9x from both sides. That cancels out over this side. But then on this left side, I have this 1x minus 9. So that will give us negative 8.
Okay, thank you.
Yep, not a problem. All right. So now remember, in order to solve, not solve, but to check our solution, we would take that value that we're calling our solution and plug it into our original equation. If I were to do that, because remember our original equation was x over x minus 3 equal to 3 over x minus 3 plus 9. If I were to do that, plugging in my x right here, notice I get 0 in the denominator. But 0 in the denominator is undefined. So you always got to remember that. It's something you always need to hold on to. Don't ever forget that. That's always going to be a thing in mathematics. It will show up no matter whether you go to calculus, trig, whatever. 0 in your denominator is a problem. And so it's just that when you get to higher maths, you would have multiple things that you can do to avoid having 0 in your denominator. So if we have 0 in our denominator after we plug our value into our equation, and let's say if you don't even check the whole thing, you at least need to check your denominators and make sure you're not getting 0 in your denominators. So see the little notes that I have right here. Since x equal to 3 produces 0 in your denominator, we cannot use it because 0 in your denominator, once again, is undefined. That means x equal to 3 is extraneous. That's what we call that if my math lab were to ask. And then since x equal to 3 is our only solution, I probably could have wrote that a little better, but only solution, only option for a solution, this means the answer is no solution. So what I mean by that is that eventually we'll get down to having more than one solution. Let's say if we had 2 solutions, let's say if we had x equal to 3 and x equal to 5, we found out that x equal to 3 was extraneous. So we couldn't use it. Well, we wouldn't write no solution because we still have x equal to 5. So that's what we mean by x equal to 3 in this case was our only solution. So that when we found out it was extraneous, that means my answer is going to be no solution because I cannot use x equal to 3. Once again, if I had more than one option, then the x equal to 5 in this case would have been my solution. And I would just recognize that I could not use x equal to 3. All right. Questions on that? Make sure we're okay. All right. Anybody still copying?
Yes.
I'm still.
Okay. All right. All right.
That x that equals 5 that just popped up right now, that was just metaphorically, right?
Yep. Just using it as an example, just to, just say if this were to have occurred. Yep.
Yeah, I got you. Thanks.
Mm-hmm. All right, we good? Am I still?
Good. I'm good.
All right. So let's look at the next one. I think this is the last one for this section. Yeah. Oh, yeah, almost last one. Last one like this anyway. So here we have 3 over x plus 6 plus 1 over x minus 2 equal to 4 over x squared plus 4x minus 12. So I'm looking at each, just like before, you look at each one of your denominators. You want to find the least common denominator between whatever you have. So I have x plus 6 in my first one, x minus 2, second one. But in this third one, I have x squared plus 4x minus 12. So I decided to factor that out, and I recognize that that is a combination of my first two. That's x plus 6 times x minus 2. Now, when it comes to factoring, this class does not go into factoring skills or anything like that, factoring methods, because they expect you to already know that coming in. So if you do have issues with factoring, make sure you get with me. I can either shoot you videos that I've done on factoring before, or if you want to, do a Zoom session outside of class, talk about factoring, then most definitely get with me. And that's an option for anything that we talk about, especially like in this section, I went back, but if you really go into the book, this section doesn't start from the beginning like I did. Excuse me. So it really starts at a place where it just hits you with problems to say, go ahead and solve. And that's because, once again, this is pre-calculus. The stuff that I started off with was basic algebra. So there are some things they are going to expect you to know, in some of these sections. That's why solving linear equations wasn't just one section. They put linear equations and rational equations, which is what we're doing now, in the same section, because they don't present this chapter 1 as a section wherein they're first introducing solving equations to you. They're treating it as if you've already been exposed to it, and you're trying to get the pre-calc stuff, not just algebra stuff. So just throwing it out there. So if there's anything that's said, same thing with add, subtracting, multiplying, dividing, fractions. If you're a little sketchy on it and you need help on it, make sure you shoot me that email so we can figure out if all you need is another video, another lecture, just to reemphasize what you remember or reassure what you remember, or we actually need to sit back and talk, and I'll make sure you're good. So just throwing it out there. So LCD, once again, is going to be a combination of each one of the denominators that you see. So I have x plus 6, I have x minus 2, and then the last one is x plus 6 times x minus 2. So I don't need to write anything twice. I would just use the x plus 6 and then use the x minus 2 as my LCD. Once again, I don't need any repeated quantities. All right. So I ran out of room, so I had to go to the next line. But this is what we did here. We multiplied. Remember, once you find your LCD, you multiply each numerator by the LCD. So the first numerator, all it had was 3 in it, but the LCD was x plus 6, x minus 2. So, still had my eraser up. So, come on, man. There we go. So that's what we did here. 3 times x plus 6, x minus 2. First one, numerator is 1. X plus 6, x minus 2 times 1. And then in that last one, the numerator is 4. X plus 6, x minus 2 times 4. So we just multiply each numerator by what we decided our LCD was. All right, make sure we are okay before we go any further.
I'm just kind of lost about how we got like the LCD.
All right, so let me do this. So we see that we have x plus 6 here, and we have x minus 6, minus 2. Those are our first two denominators.
Yeah.
All right. Our third denominator is here, but when you factor it, you got both of those first two denominators. All right. So you see that? You're cool with that?
I think it's just been forever since I like last factored, so
Yeah.
I think I just
Yeah.
need a review of factoring.
Okay. Yeah. So then, so whenever you factor, remember this is just x times x is x squared. That's negative 2x, and then here plus 6x, negative 12. And so that is our, expression right here. So, like I said, we may have to go back to, looking over factoring, and making sure you're good with factoring. But that trinomial factors out to give you a combination of these first two denominators. And so whenever you have that type of situation, all you would do is write down for your LCD the quantities that are not repeated. So x plus 6 is going to be a part of our LCD. X minus 2 will be a part of my LCD. I already got that here, so I don't need to write another one. But let's just say if I factored it and x minus 7 was a part of the factorization, then x minus 7 will be a part of my LCD. Every different quantity that you see will be a part of your LCD. Right. All right, so any more questions on that before we go any further? Make sure we're good. All right, so like I said, though, if anybody having issues with that factoring piece, make sure you shoot me that email so we can see about making sure you're okay. Because even just doing one factorization, may not, solve all your concerns about factoring. So make sure you get with me on that. So now the next step is to reduce or simplify. X plus 6 will cancel, the whole quantity of x plus 6. Here, the whole quantity of x minus 2 cancels. And then here, x plus 6, and then x minus 2 cancels. So what that leaves us with is this right here. No fractions involved. They already canceled out for us, but that's 3 times x minus 2, 1 times x plus 6, and then in that other part, the whole 4, only 4 is left. All right, questions. All right, so now we'll distribute 3 times x, 3 times negative 2, 1 times x. Oh, Mr. 1. If it was another number, it would matter, but it's just 1. But that would be the process. 1 times x, 1 times 6. Then we combine our like terms. So 3 times, or not 3 times, but 3 plus x is 4x. Then we have negative 6 and positive 6, so they actually cancel. And that leaves us with 4x equal to 4. And then to finish it off, we divide both sides by 4, and our answer is 1, x equal to 1. All right, questions? Any questions?
Do you think you could scroll up to the top real quick?
Mm-hmm. See if I can get all of it in there. Be too small. But yeah, that's the beginning of the problem right there.
Thank you.
Mm-hmm. Are we good to go? Or
Yeah, I'm good.
oh, okay. All right, cool. Anybody else still copying this bottom part before we scroll up? Got two more relatively simple problems especially compared to what we just did. But it's just two special scenarios that I want to make sure you're aware of before we leave. All right. So next one. Original problem is right here. 2 times x plus 1 equal to 2x plus 3. First thing we would do is distribute. And that'll give us 2x plus 2 equal to 2x plus 3. All right. So now we want to solve for x. That means we need to get all of our terms with x on one side, all of our terms without x to the other. So we can go ahead and subtract 2x from both sides. So we have to be careful here. We cannot be afraid to let math happen. So in other words, if I were to subtract 2x from one side and it cancels out, then it should also cancel out on the other side as well. So oftentimes what happens is a lot of times people subtract 2x from one side, and let's say they cancel out on the left, it'll be 2, but then on the right, they still write x plus 3 because they want, they're scared to let it cancel out completely. So, but if a 2x minus 2x cancels out on one side, and 2x minus 2x cancels out on the other side as well. And so what that leaves us with is 2 equal to 3, which is a false statement. All right. So that's what I have right here. 2 equal to 3 is false. Now your answer isn't false, but what you have is a false statement. You could have also came down with, 0 equal to 1 or negative 1 equal to 0, depending on what process you decided to go with, what number you decided to move first. But either way, you still have a false statement. So this is what we come across. If our variables canceled and we ended up with a false statement, our answer is actually going to be no solution. So once again, if your variables cancel and you end up with a false statement, your answer is no solution.
So the variables cancel when the symbols are the same and it equals 0?
When you say symbols, are you talking about the whole 2x and 2x? I should have been over here.
Yeah.
Yep. And so when they cancel out and you end up having something that's not true. So 2 equal to 2 is true. 3 equal to 3 is true. 0 equal to 0 would be true, but 2 is not equal to 3. So that's what we mean by being false.
Okay.
So if your variables cancel out completely and you have a number equal to another number that, of course, that's not the same, then that's considered a false statement. And that means your answer is no solution.
Okay.
All right. Going to the next one, very similar. So the next one, we have 4x plus 6 equal to 6 times x plus 1 minus 2x. So combine your like terms. Over here, we have 6x minus 2x. That'll be 4x. So that gives us 4x plus 6 equal to 4x plus 6. So I'm pretty sure you can see that this is going to go in a different direction than our last problem. So we subtract 4x from both sides, our variables cancel and give us 6 equal to 6, which is true. And so we're looking at this scenario now where your variables cancel and you end up with a true statement. Your answer is all real numbers. So in the previous example, there's no number that you can plug in that will be considered a solution. So there's no number you can plug in that will make that equation a true statement. In this one, no matter what number you plug in, it will work. You can plug in anything and both sides will equal out to be true. All right, questions. All right, any problems before we scroll up? All right. So that's my email address. If anybody didn't have it, vtucker@tcc.edu. Always a way to contact me. That is 1.2. Next class we'll look to get into 1.3. And you know, this only reason this even ran, you know, this long, this section ran this long is because, you know, we did all that introduction stuff and everything like that. But you know, as I mentioned before, you know, all our lectures will be recorded. I will be sending them to you guys at some point before the week is out. Also, don't forget, you know, you want to stay on top of your work. We only have 10 weeks, you know, to get through our assignments. So make sure you stay on top of it. And of course, if you have any issues, make sure you keep me in the loop. You don't have to tell me deep, intimate details. But if you have any issues or whatever, and there's anything I can do to help, most definitely let me know. And then we'll go from there. Let's see, someone said something in chat. Right now, we don't have a due date. As we progress, as we get closer to closing out chapter 1, I'll put a solid date out there. But right now, we kind of playing it by ear, depending on how we move, according to the lectures and, you know, the class and everything. So when we get closer, let's say, I think this section, last section in chapter 1, is 1.7. So when we get about 1.5, 1.6, you will look to put a due date out there. And normally my due dates are on a Sunday. So do it like that. All right. Anything else? Anybody else?
Is the first section open to start the homework?
Yes, everything's open.
Oh.
Yep, everything's open. So if you nice with it and you want to, do chapter 1, chapter 2, I mean, whatever you want to do, you can go ahead and get in there. Yep. Will all due dates only be posted on Pearson instead of, right, all of your due dates are in my math lab. The only reason I use Canvas is just to archive your emails. So that's the only reason. As far as communication, I'll shoot you emails through SIS. Like I said, I just archive your emails in Canvas. So all of your grades, all of your due dates, everything you really need is in my math lab when it comes to your assignments. So I was trying not to create multiple places where you have to go, just one central location or one central portal that you would go to get all of your assignments and do all of your assignments and see all of your grades as well. Somebody unmuted? Yes.
I have a question. I am muted because I think I'm waiting for the VA to send me my book stipend because I did take your class last semester and a semester before that, but I think that my year is up at this point.
Well, that is going to be, you talking about for my math lab?
Yeah.
Well, you can't use that anyway. That was a different book. Yeah.
Okay.
Yeah, once you switch books or switch courses, like you can't use that code again.
Well, I think I used it because I used it for your.
You know what? I think you did get away with that. That's not how it's supposed to work. I think that's what happened. You got away with something that wasn't supposed to work. But yeah.
Okay.
But if it worked, hey, You know, I'm not a snitch, man. Snitches get stitches. I didn't go tell anybody.
I was like, yeah, I didn't buy. I don't think I bought it. I don't know. I had them.
Yeah.
I don't know if I bought it again, but I think I didn't
Uh-huh.
have to use a new one because I took your statistics and
Right.
quantitative reasoning. So
Right. So
okay.
yeah, I mean, hey, try it out. Look, try the old one, see what works. I mean, you know, can't hurt but to try. You know what I mean? Can't hurt it. So yeah, it's all
Yeah,
good.
I'm gonna try to get the
Mhm.
go to Barnes and Nobles, or I had to fill out some paperwork for the VA, so waiting for them to send my stuff.
Okay, yeah, not a problem, not a problem. So anybody else? I know Philip has some questions about his account specifically, so I'm going to address his questions in a second. Anybody have any more general questions before I let everybody go? Everybody straight.
Yeah, I wanted to clarify something. Listed in the My Lab under homeworks, it says assignments section 1.2. So that's not due?
Well, you should be getting in there and starting work as soon as possible. Now, as far as is it due by the next time I see you? No, but there will be a due date that's going to be assigned to it coming soon. I just don't know what that due date is going to be because, because a lot of times I take a feel of my class and try to, if it feels like we've talked about enough for today, if I feel like I've been talking a lot, I know that means y'all know I've been talking a lot, then I might cut a lecture short. You know what I mean? So if that's the case, then me just saying, okay, we're going to do 1.4 and 1.5 today, but then I decide to cut it back, then now my dates are going to be, I'm going to have to change them anyway. So instead of putting something out there that I'm going to have to possibly change, I just get a feel for how we're flowing. Then when we get close to closing out the chapter, then I put a due date out there. All of chapter 1 stuff need to be done by this date. But I'm assuming that as we're progressing, you're actually doing the work anyway. So it's not like you're just getting started on chapter 1 stuff when I put a due date out there. It's like you guys are supposed to be doing this stuff as we progress along. And then once you see that due date, okay, this is when I have to have stuff finished. So.
Okay, thank you.
Yep, not a problem. Anybody else? So once again, on that due date stuff, we just covered 1.2. You do not have to finish all of 1.2's homework by the next time I see you, but you do want to start working on it, And so that's how I'm looking at how you guys should be attacking your homework. All right. So if you guys are good, I'm good. I will see you on next class. We'll get into 1.3. Outside of that, y'all have a good day.
Yeah, have a good day, sir.
Thanks. You do the
Bye,
same.
Professor.
Take care.
Thank you. Have a good day.
Thanks, y'all. Take care. All right, Mr. Phillip, what you got, sir?
Just the username and the password to get your Pearson account.
Okay, so now you have to create your own. When you let me go there. Hold on a second. I want to make sure we're talking about the same thing. All right, so you go to register as a student. Register now. Hit Tucker. I don't remember what ours is. I'm just clicking anything. Oh, that one don't even work anymore. Yep. Okay, what was it first?
So I use Pearson with another class. Does that mean I can use the same account?
Yes, you should be able to.
Okay.
Mm-hmm. Yep. Now the access. Now what? It wasn't 161 before, was it?
No, it was for my public speaking class. So it's a different access code.
Yeah. Right. Okay. No, I was just trying to see, just that's exactly where I was going with the access code part. But yeah, you still should be able to use the same account though.
Okay.
All right. So Philip, we got are you talking about right here when you say user ID password?
Yeah.
Yeah, so have you ever used Pearson before?
Yes, I have.
Okay, so now if you want to use your old account, that's what your classmate was alluding to just then. You can use your old information here. But I don't have access to that. So now if you don't either, you don't remember it, you can, if you use your TCC email, you can forgot your username or password. Or if you really want to use that, you can always call tech support or customer service. They can help figure out what that is. But if you just want to start a whole new account, you can just hit create account and just put in some new information here.
Okay, let me do that.
Okay, just to double check with you, I know you've probably said it a million times already today,
It's all good.
but everything's gonna be on my math lab and I'm not gonna find anything on Canvas.
Right.
Okay, because all my other classes were on Canvas.
Yeah, and so the only reason I'm not using it that way is just that because my math lab has everything you need. And so, like I said, I didn't want to create multiple places for you to have to go because I can't put, I don't know, maybe it is a way, but I just didn't see a need for it when, trying to embed my math lab into Canvas when all you have to do is just go to my math lab.
Yeah, Canvas is already confusing enough.
Okay, well, no, I'm glad that we're on the same page. They're cool.
All right, have a good day.
All
Thank
right,
you.
thanks. You do the same.
So is there an access code that I gotta put in?
Okay, Mr. Connor. Yep, no problem, sir. Now your access code is the one that we just was talking. That was Tucker. Hold on. Okay, no, getting them confused. I gave you the course ID. Now your access code is what you would purchase through Barnes and Noble.
Okay.
Okay. So now, if you can either purchase that through Barnes and Noble, or you can purchase access through Pearson itself. But if you're paying through financial aid, then you have to go through Barnes and Noble. But if you're going to pay with your own money, you can actually pay for your access through Pearson itself. And then from there, it will let you in. Now, if you don't want to pay for anything right now, you can use the 14-day free pass.
14-day free pass.
Yeah, it should be a link, a little sentence at the bottom of your page.
Okay, I'm using a 14-day.
Okay.
Then you push go to my courses, right?
Yep. Mm-hmm.
No. Okay, I'm in there now.
All right, sounds good.
All right.
All right, man. You have a good one. Let me know if you have any other issues.
All right, you have a nice day.
All right, thanks. Do the same. All right, anybody else before we close out? Everybody good? All right, take care. Have a good one.